So now let us start creating our first class. So we know a class is a blueprint used to create objects. So let us create a class student, supposing, and let us use pass as a placeholder for now. Let's try to print student. And now a class is created. Next, let us create an object. So how do you create an object? An object is a real instance of a class. So now that you've created a class, you can create an object. Let us create S1 as an object. You mention the class name. Alright. And then let us print S1 now. So yes, an object gets created. Alright. Next, we discussed about constructor init, right? So the constructor is automatically created whenever an object is created. So we have the class student, right? We create a class. Let's comment it out. Using we have this class student. So now we define the init method, which takes self as a parameter, supposing, and you print. Let us write constructor executed. So now on creating an object S1, let us run it. Get constructor executed. Alright. So the constructor is automatically run whenever an object is created. Next, we have constructor with attributes. So here we were taking just one attribute, self. So now we can take more. Let us create a class student again. In the init method, the constructor, we'll have self. We'll have name and age as attributes now. Let us initialize these. Self.name is equal to name. This is how you initialize. And self.age is equal to age. So here self is the calling object. Now let us create that object. For example, S1. You mention the class name, and in brackets, you'll mention the name and age, the arguments. Supposing we write Ananya and the age as 20. Now, on printing S1 dot name, let us try to assess these attributes and see whether they work fine or not. So yes, on printing S1 dot name, we get Ananya, and printing S1 dot age, we get 20 as the age. Alright. So attributes store information about an object, and using the dot operator, you can assess those. Now let us try to create multiple objects with its own data. So every object will have its own data this time. We have created S1 as an object. Now let us try to create S2 as another object. We'll mention the class name, and in brackets, we'll mention the name. Alright. So now let us try to print S2 dot name and S2 dot age. So this time we should get Rohan and 30. So for S1 dot name and S1 dot age, we are getting Ananya and 20. For S2 dot name and S2 dot age, since we are trying to assess the object S2, we'll get Rohan and age as 30. Okay, so every object stores its own data. Next, we have the self parameter. Let us understand it through a program. What is the purpose of self? So we know self represents the calling object. So we have class student. Okay, let us comment this. 1 second. And now let's create this class student. We'll use def in it, and inside it we'll have self and name as parameters. Okay, so on initializing, self.name is equal to name, and then we create another method. Let us create the display method. Okay, and we'll pass self as a parameter in this one. We'll print hello and then self.name. Okay, here self acts as a reference. Let us create two objects, S1 and S2. Okay. Now let us try to use the display method. So when we write S1.display, and let us do it similarly for S2.display. Let us have a look at the output. So we get hello Ananya and hello Rohan. So it should have been Rohan here. And on running this, we'll get this as the output. So self represents the current object that is calling the method. Okay. So here self acts as a reference or the calling object itself. Next we have methods inside a class. So methods define what the object will do, right? What an object can do. Now let's take a different class. Let's take class dog. Okay. And we'll create a method. Let's name it bark. Pass self as a parameter, which refers to the calling object. It should print. I'll say this. Okay. So now let us create an object D1, suppose. We'll mention the class name. And then on calling D1 dot bark method, you'll get this. Right? So the methods define what an object can do. Here bark method, on calling the bark method, it will print this. And this is how you call a method. Object name dot method name. Okay. Next we have methods using attributes. So methods can assess the object using self. Okay. So let us create a class student and we'll mention the init method to initialize the attributes. We'll write self.name is equal to name. And now let us create another method, introduce. Okay, let us create this introduce method, which takes self as a parameter. So it should print, hi, I am, and then it should print self.name. Let us create an object now. Let us pass the name and make the call. So we'll call the introduce method. And let us see. We get hi, I am Anna. Right? So this is how you can call a method using attribute. Methods can assess the object data using the self. Alright, so self parameter helps us assess the object data. Here we are using self.name to assess the object data. Now, what if you want to modify attribute? So you can modify an attribute easily. And now let us see how we can do that. So methods can update object data. Supposing we have class student and we define the init method. Let us take self and name as parameters and then initialize the name attribute. Now let us create another method, supposing change name. Okay, supposing we want to modify the name. So we'll take two parameters here, self and new name. So now we'll replace self.name with new name. Okay, so this way you can modify. Now let us display this name. We'll have only self as a parameter. And then we want to print self.name. Okay. Now let us create an object after creating a class. And let us pass the name as Ananya. And then using the dot operator, let us call the display method. So we'll write s1.display object name dot method name. And now let us change name to, let us pass a new name now. Let us pass Anna. And now again, let us display. So let us see what change we see. So earlier on using s1.display, this one, we get the name as Ananya, right? Because we are using this one. So we get Ananya and then s1.change name will modify the name to Anna. So from Ananya, now we have the name set as Anna. So now on using s1.display, we'll get Anna as the name. Okay. So this way you can modify an attribute also. Next. Okay, so now I want to explain to you the concept of encapsulation, inheritance, and all of that. So let us see. Let us take the example of a bank account. Let us create this class bank account. Okay. And then init method will come self and the balance. Right. Let us initialize self dot balance with balance. And now let us create another method, which is the deposit method, supposing. So self, comma, amount. Now supposing whatever amount we will deposit, it will be added to the balance, right? So self.balance plus equal to amount. Next, let us create another method, withdrew method. It will take self, comma, amount again. And now balance में से ये withdrew हो जाएगा. So minus equal to amount. And after that, let us create a method show balance, which will display the balance. We'll have only one parameter, which is self. And it should print the balance. So we want self.balance to be printed, right? Self will reference. Let us create an object ACC. We'll mention the object name first. And then in brackets, you'll mention the balance. So supposing, let's take balance as 1000. Now, let us see the balance first. Okay. So we'll write ACC.showBalance. Now let us use the deposit method. So acc.deposit. Supposing we want the amount to be 100. Let's take it 100. Alright. And then we'll write acc.show balance. Let us see the balance again after depositing 100 rupees. After that, let us use the withdraw method as well, right? So let us use the withdraw method. So on withdrawing, supposing we withdraw an amount of 200. And now we want it to again show the balance. Okay. Now let's run this. 1 second. And here also. Let us run this. So we get balance as 1000. Here we're setting the balance as 1000, right? So this is executed now. We get the balance as 1000. Next we have acc.deposit 100. So now let's go to the deposit method. Now the balance will get increased by the 100. So now the balance becomes 1100, right? So this is executed now. Next we have acc.withdraw of 200. We'll go to the withdraw method now. Amount of 200 is withdrawn. So it will be subtracted from the balance. Balance was 1100. So 1100 minus 200, we'll get the balance as 900 now. So even this one is executed. Okay. So using the bank account example, we have understood that objects can perform different operations using methods. So we can perform a number of operations. Now we have inheritance. Before moving to inheritance, let's just comment this one, right? And now let us move to the concept of inheritance. So what is inheritance? When a child class inherits the properties of parent class, right? We can say derived class takes the properties of the base class. Let us create a class supposing animal. Okay. And we create a speak method which will print so here animal will act as a parent class. Okay. After creating the animal class, let us create another class which is the dog class. It will inherit properties from the animal class. So dog will be a derived class now. Let us create another method, bark method, which will print, let us say, this. Okay. Now, after creating the classes, it's time to create an object. Let us create the object and call the methods. So, we're calling d.speak. So always remember that since dog class is a derived class, it will have both the methods which are included in the parent class, here speak and bark, both will be there in the child class, right? So both can be accessed easily. It will not give you any error. So on running this, we'll get, for first d.speak, we'll get animal speaks, and then for d.bark, we'll get the dog barks. So this is the concept of inheritance. Right? Dog is inheriting the methods and properties of the animal class, the parent class. So a child class inherits the properties and the methods from a parent class. We term it as inheritance. Next, we discussed about multi-level inheritance. right? So one class inherits from another, then forming a chain, and the chain continues. So let us create a class. Supposing the best example could be the grandfather, then father, and then the son, right? So let's create a grandfather class. Okay. Let us have a method house in it, which will print owns a house, supposing. Then next, let's create another class, which is the father class now, which will inherit properties of grandfather class, right? After that, we'll create another method. Let us see. Let us create a method car, supposing, and print that he owns a car. So we are done with our father class now. Let's move to the son class. Right, so now it will follow multi-level inheritance. Let's create another method. And this should print. Alright. So now, after creating these classes, let us create an object. Right, so let us name it as S. Alright. So now let us call the methods. Let's call house first. Then car also. Use the dot operator here. And then bike. So all the results are displayed over here. So what we understand from this is that the son class here inherits from the father class and as a result from the grandfather class as well. Right? So the properties and methods included in son will be which all methods? House, car, and bike will be included in the son class. Right? Then in the father class, we'll have method which is car and house only. Grandfather will have only the house method. So this is all about multi-level inheritance. Then there is even multiple inheritance. So there's a difference between the two. Let us understand it. Supposing I create a class father and then define a method which is money. I want it to print now. Let us create another class which is mother. And then it should print alright. So now we'll create the child class. It will inherit properties of both father and mother. So this comes under multiple inheritance. Okay. So this time it isn't multi-level. Multi-level mein we had grandfather, then father, then son. And in multiple we have father, mother, child, where child takes the properties of father and mother. Okay. So let us have nothing over here. Let us keep pass as a placeholder. Now let us create the object child. And we can assess the method which is there in father class and even the method which is there in the mother class. And we'll get this. Father's money and mother's children. right? So in multiple inheritance, a child class can inherit from more than one parent class. Here we have more than one parent class, so which is father and mother. Okay, so this is the difference between multi-level inheritance, this one, and the next which we just discussed, which is multiple inheritance. Okay. Next we have the concept of method overriding. So what is method overriding? The child class replaces the parent's method with its own version. So the method name is same, but you override it in the child class. Supposing we have class animal, always remember that for method overriding, inheritance is necessary. So let us create sound method. Supposing it should print animal makes sound. And now let's create the class dog, which inherits the properties of animal class. Here dog is the derived class now. And create a same method, but it will perform some other operation, some other function. Right? So we are overriding the same method here. Now let us create the object and call the method which is d.sound. Okay. So now you will get dog barks. Right? So this method is assessed. This is an example of method overriding. Next we have calling the parent method using super. Supposing we create a class animal. Now we create a method sound which will print animal sound. And now let us create another class, supposing animal. We have already created, we'll create the dog class which will inherit properties from the animal class. Now we'll have the same method name, supposing sound. And let us write super sound dot super dot sound. And then print. After this, we'll create the object. And then using the dot operator, call the method. So on running this, you will get animal sound first and then dog barks. Right? So using the super, you can call the parent class method as well. This is how you can use the super method like we are using over here. Next we have data hiding, encapsulation. Let us create private variables now and private methods and see. So we'll create the init method now. We'll take self and balance. Let us initialize it. So here we are creating a private variable. Double underscores makes it private. Okay. Now let us create another method, show balance. And make it print this. Now it's time to create the object. Let us quickly create it. We'll pass the balance. And now we'll call the function. The method show balance. So here we are getting 5,000. But if we try to access the private variable outside, then we will get an error. Supposing I try to access this variable, which is private. So we will get an attribute error saying the bank object has no attribute, right? Because it is private and it is not accessible by us. I hope it is clear. So private variables can be accessed in the methods of the same class. They cannot be accessed outside the class. So now, supposing you want to modify the private data. Let us see how we can do that. Just a second. So now, to modify the private data, we can make use of methods that are there inside it. Okay. We create a private variable. And now we create another method, which is the deposit itself, comma amount. Let us say we will update it now, plus equal to amount. Okay. Another method show, which should print the balance. Now the object ACC, we'll write ACC is equal to class name and in brackets the balance argument. Let us call the method object name dot method name. Supposing we deposit amount of 1,000 and then ACC dot show. So on running this, what are we getting? Let us run this. Have we not created? Okay, there's an indentation error. So now let us run it. So now we get 6,000 because self dot balance, the balance is increased by 1,000. So 5,000 plus 1,000 will give you 6,000. So you can access the private data using methods and then modify the private data accordingly. Okay. Next, to the help of a program, let us understand polymorphism. Polymorphism, as the name suggests, means many forms. So the same method name behaves differently for different objects. Let us quickly write a program. Take some methods in it. Okay. Now another class, cat, supposing. Now, this is an important point. How you make use of polymorphism. So we create animals as an object. We write for animal in animals. We want animal.sound to be printed. So on running this, we get both, right? So the same method name behaves differently for different objects. Here for dog, using the method name, which is sound, we get bark. And for cat, using the method name, which is sound again, the same method name, we get a meow. So this is the concept of polymorphism. Next we have method overloading. So Python doesn't support the traditional method overloading, but you can do it using default arguments or variable length arguments. So let us try it using default arguments first. Supposing we create a class demo. And then you define the display method. In it, you put some conditions. Supposing if name is none, we want it to print hello. And if there is a name, we want it to print hello and then the name. So it depends on the number of arguments that you are passing. Right? Hello and then we want it to print the name. Okay. Let us quickly create the object and then use the display method. And then display of. So for one, we have it as none. We are specifying no name. And in one case, when we are making the method using the dot operator to call the method, we are passing an argument as an unknown, right? So we are getting an error, def display. So we are missing a colon over here. Let us run it. So yes, for the first case, the if condition is being followed. Since we are not specifying any name, it is considered as none and we get a hello. And for the next one, which is d.display of Ananya, we are getting hello Ananya. So the else block is executed. Okay, so this means Python method overloading in Python is done using the default arguments. Similarly, you can do it using star args that we discussed, right? So let us try to do it with that as well. Moving on, let us create a class calculator this time and define the add method, which will take self and then numbers, let us suppose. Okay, so it is variable length. Using the sum function, we are trying to calculate the sum. Now we'll create the object and pass different arguments for each call. So in first we are passing 2 arguments. In next, let us pass 3 arguments and let us make another call in which we will pass, supposing 4 arguments. Let us see what results we get. So when we pass 10 and 20 as arguments in the add method, we are getting the sum as 30. When we pass 3 arguments, which is 10, 20, 30, we are getting 60 as the sum. And for the last case, we get 100 as the sum. So star args allows passing any number of arguments. So this way you can practice method overloading in Python. Next, we have the concept of abstraction. So what is abstraction? Showing just the essential features and hiding the implementation details. Only the essential features are displayed. So we have discussed this in our theory lecture. We write from ABC, import the ABC module, comma, abstract method. Right? We write here abstract method. Next, let us create a class shape. Supposing we write, we see over here. Now, at the rate abstract method, you'll start defining your first method, which is area. So in this class, we do nothing. We'll pass as a placeholder. Next, let's create rectangle, which inherits the properties and methods of shape. So using the init method now, let's quickly initialize the variables that we have. So self dot L is equal to L and self dot B is equal to B. Alright. Next, let's define the area method. Let us make it return self dot L into self dot B. It's finally time to create the object. Let us pass length as 5, breadth as 4, and ask it to print r dot area. We are using print statement here because in the method definition, we have a return. So we'll get the area as 20. This is a simple example of abstraction. Okay. Now, after completing all the things which were the important concepts of OOPS and Python, let us do a mini project. Let us try to create a student report card, supposing. We'll try to do all of this by making use of a combination of constructors, attributes, methods, inheritance, overriding, encapsulation, right? All these concepts in just one program. Let us try to create it and test whether we have understood everything or not. So let us create a class student. So we'll be building a student report card program now using OOPS. So we are creating a class which is the student class, and now we'll be writing the init method. Right? We'll write the init method. We'll have attributes as self, name, and marks. Okay. Let us quickly initialize self.name as name and self.marks is equal to marks. Okay. Now, let us create a display method, which will firstly display the name and then the marks of the student. So name, comma, self.name will reference to the name, and then we wanted to print the marks. We'll write self.marks. So self refers to the calling object. It will give reference to the marks. Okay. Another method, let us create grade. Let us put some conditions over here. If self dot marks, here, since we want not everybody to assess the marks easily, so we'll make it private. Let's make it private. Okay. So if self dot marks is greater than equal to 90, it should return, let us say A. If self dot marks is, let us say, greater than equal to 75, then it should return B. Alright. Else return C. Now create another class. Let us try to find out the toppers. So we'll create a class which is the toppers, which will inherit the properties and methods of the student class. So we are making use of inheritance over here. So def grade. So this is method overriding, right? So we'll print outstanding performance. This is how it actually happens in the real life as well. So we are creating a similar example, a similar program. And then it should print the marks also, the grade which the student is getting. So for grade, let us use the super. We discussed it before. Let us make use of that now, right? And finally, we'll create an object S1. Let us have some name over here. And then S1.display, supposing. Okay. We even wanted to display the grade method. We have written self.mark somewhere. So yes, this was private. So we'll write this. So now, firstly, let's comment this out, right? And now run it. So this time, the name gets displayed, Anna, right? We have the name. When we use s1.display, we go to the display method in topper, right? This one. So it will show the display the name first, which is Anna, and then the marks, which is 95. So private methods or private variables can be assessed by methods in the same class only. Right? So that is why you get the marks. Next, s1.grade. We come over here to this one. Firstly, outstanding performance is displayed on the screen. And then using super.grade, this method is assessed. And we get a grade of A. I hope it is clear. Right? So this was all for OOPS in Python. In the next lecture, we'll be starting with file handling.